Hi, welcome to a continuation of talking about GIS. Last week, we went over just some of the basics of geography, coordinate systems. And this week, I want to get a little closer into GIS itself. And so this is just, this is still an introduction and talking about some of the basic concepts of GIS. Now, for context, I'm going to be following along. I'm going to be following along with the GIS Commons. This is kind of our textbook. It is not exactly a textbook. It's an online website that covers a lot of the basics of GIS. And it has a framework of dividing it into the introduction that we're talking about today, how to get information into GIS, how to process and edit the data, both map and data processing, analysis of data that we'll get to later on, and how to share the information, how to get information out of GIS. Okay, so today I'm going to cover a little bit of the aspects of the introduction, and I'm going to do these in PowerPoint, but this should roughly coincide with the introduction chapter. These are very short, so I expect you to read them, of the GIS Commons that we're using as our textbook. Okay, first off, what is GIS? We talked a little bit about this last week, but different authors have various ways of defining it, most of them having to do with something of a collection of hardware and people and stuff that support the management, analysis, and display of spatial data. Another way to look at it is the framework of the GIS Commons, which breaks it down into these subsystems that we were looking at. Input, that's getting information into the GIS. Processing, how to manage the information and edit the information to make it usable. And then once we have the information that's usable, how do we analyze? How do we ask spatial questions using the data that we've brought into the system and that we've processed? And once we've done our analysis, how do we share our analysis? How do we have output, generate thematic maps, multimedia, online maps, and that sort of thing? And so I think for us, especially learning GIS, that this is going to be a helpful framework of understanding GIS, rather than trying to make a rigid definition, is kind of understand it by doing it, by doing these different steps. It just is what it is. You bring stuff in, you edit it, you analyze it, and you share it. So to me, I think that's a very helpful framework. But to understand what you want to bring in, how you want to edit it, what you're going to do for analysis, you need to back up a step and understand, what am I trying to accomplish? And a good way to think about that is the concept of spatial questions. So I think at the very beginning of a GIS class, it's important to emphasize that you need to have a question that you're trying to answer in order to really use GIS effectively. The text mentions 5 generic types of geographic questions, like what is that? So if there's a certain place on a map or on the earth, you can ask, well, what is there? And that's going from the location and working your way outward. Like you have a location and you're asking, what is at the location? And another way to flip that around is, you have a feature, you want to understand, where is that feature? Where are schools? Where are hospitals? GIS can also have a temporal component. You can look at change over time. What has changed since? How has the urban boundary of Fresno changed since the 1960s? How has agricultural land use, crop types, changed in the last 20 years? And you can look for spatial patterns. What is the distribution of how randomly distributed are whatever kind of phenomena that you're studying. And also, as part of analysis, you can do what we call prospective modeling. What if we were to put a new fire station at such location? How would that affect our service of this neighborhood? Or if we were to change zoning, how would that affect the urban landscape? And so these are the types of questions that are amenable to using a GIS. And I'll give some other examples. This is from a previous textbook that we used. They had some examples. And so rather than giving those vague kind of, vague kind of generic questions, these are some real questions. Like, so for law enforcement, a geographic question may be, where in the city are the majority of drug arrests made? Where do most of the violent crimes occur? Is there a spatial relationship between these two variables? So somebody who's a criminology major, this may be the type of thing that would be applicable to them. If you're a business major and into urban development or city planning, you could ask questions like, what is the slope of the land in this area? Is it too steep for development? In real estate, you might ask, what is the average price of homes in a neighborhood relative to those in nearby neighborhoods? Could be university admissions administrator. If you're working in education, where do most of the students that apply, where do they live? Where are there economically disadvantaged areas? How can we attract more applicants from these areas? If you're working as an aid worker, where's the area of greatest human suffering and greatest property damage? How can we maximize the impact of our relief efforts? So if you work for the Red Cross, for example, you may want to target relief to areas where the need is greatest. Or if you're into logistics, a delivery truck driver, what is most effective, or even canvassing for politics, what is the most effective route for my 25 deliveries today or my 25 canvassers if we were trying to advocate for something? Or in politics, where should we draw congressional district boundaries so that all the people in a large city are represented in Congress equally? And oftentimes this gets flipped around, where how can we draw districts so that it's most advantageous to a political party? That's called gerrymandering. So if you ever hear about gerrymandering, political districts being drawn to advantage one party over the other, GIS is often a key technology that's used for that. Or, something relevant these days, if you're the Center for Disease Control and Prevention, was a geographic distribution of people currently affected by a disease, maybe like COVID or something else, and how many people in the immediate vicinity could be infected. And so all of these are different areas, and these are different types of applications, but they all involve spatial questions. If it involves where something is, if it involves space, then GIS is a tool that can be used to help answer these questions.